Data Visualization Basics, Histograms, Boxplots, Scatterplots. Welcome! In this lesson, you will learn how to create simple and powerful graphs. We will use real datasets to make concepts easy and practical. By the end, you will know how to explore and share data with clear charts. Let us get started. Running the cell now. First, let us import libraries to help us work with data and create charts. We will use Pandas for data, Seaborn and Matplotlib for drawing. We will load the tips dataset. It has information about restaurant bills and tips. Let us peek at the data. This command hides warning messages so our output is clean. We import Pandas. That helps us handle tables of data. We import NumPy to help with calculations and random numbers. Seaborn is a modern chart library. It is built on top of Matplotlib. Matplotlib is a popular plotting library. Seaborn uses it to draw charts. This section loads the tips dataset from Seaborn. It is a classic example for learning. We print the shape, which tells us how many rows and columns the data has. Here, we show a small part of the data table. Running the cell now. Practice. What do you notice about the dataset? Try printing other columns to explore. What is a histogram? A histogram is a bar graph that shows how many data points fall within certain ranges. It is great for seeing patterns, like how spread out tips are or which values are most common. Running the cell now. Now, let us see how tip values are distributed by making a histogram. We use Seaborn's histplot function and set colors for better style. The line on the graph is called a KDE. It shows the smooth shape of the data. This comment tells us we will plot the tips in a histogram. This sets the size of our plot so it is easier to see. We use Seaborn to plot the column tip into 10 groups. We add a smooth curve. A title helps us know what the plot is about. The x-axis label tells us what the numbers at the bottom mean. The y-axis label shows how many bills are in each group. This line displays our chart. Running the cell now. Try changing the bins a value to see how grouping affects your histogram. Why are histograms useful? Histograms help us spot patterns quickly, like whether tips are usually small, large, or somewhere in between. They are helpful for finding odd or surprising values too. Running the cell now. Let us examine how total bill values are spread out in the restaurant. This helps us spot if most bills are similar or if there are a few very large or very small checks. We switch now to exploring total bill amounts with Seaborn. This draws the chart with more bins to see detail in the spread of bills. A new title shows us what the data stands for. The x-axis label describes the value for total bill. The y-axis tells us the number of bills in each group. We display our chart. Running the cell now. What do you see here? Try plotting other columns like size, which means number of people at the table. What is a boxplot? A boxplot is a smart graph that summarizes data using minimum, lower quartile, median, upper quartile, and maximum. It quickly shows if data is balanced, if there are outliers, or if most values are high or low. Running the cell now. Let us make our first boxplot. This plot makes it easy to notice the range, center, and outliers of tip values. This comment describes that boxplots show summary and outliers for tips. We make the plot wide so details are clear. We use Seaborn's boxplot to display tips. The color orange stands out. A simple title tells us what our plot shows. The x-axis label points out measurements of tip size. We show the plot now. Running the cell now. Try changing df, tip, to df, total_bill, to see if outliers are different for total bills. Now, we will compare tips across different days. Boxplots for each day show us if one day has higher or more spread out tips. This comment marks that we want to compare tips spread by day. The plot is wider again to fit all boxes in. We plot tips for each day of the week using colored boxes. We give the plot a meaningful title. We label the x-axis with days. We label the y-axis with tip values. The chart is displayed. Running the cell now. What differences do you see? You can try boxplots for columns like total_bill too. What is a scatterplot? A scatterplot lets us see the relationship between two variables. If points go up together, that means as one value increases, the other tends to increase. Scatterplots are great to spot clusters, trends, or patterns. Running the cell now. Let us make our first scatterplot. We compare total bill versus tip to see if bigger bills have bigger tips. We can use color to show gender and shapes to show lunch or dinner. We mention that we want to show the link between bills and tips. We set plot size to see details better. Scatterplot uses bill sizes on X and tips on Y. Color and style give us extra info for gender and meal time. The plot has a clear title. The X-axis label tells us the size of the bill. The Y-axis label marks the tip amount. The legend reminds us what color and shape mean. This line draws our finished chart. Running the cell now. Try changing the hue or style column in the code to check other effects. You can try a smoker or size. Let us add a trend line to our scatterplot. The line helps us see if there is a consistent relationship between bill size and tip size. With Seaborn's regplot, we can show both dots and a fitted straight line. We set the points to be a bit see-through so overlap is easier to spot. The line is red for focus. This chart is titled to say what we compare. Again, X labels show bills. And Y labels show tips. The output makes the chart appear. Running the cell now. Notice, if the line goes up, it means generally larger bills get bigger tips. Handling missing data for visualization. Sometimes data has missing values. It is important to handle or fill these so charts do not break. Let us check for and fix missing values. Running the cell now. This small code chunk checks each column for null or missing data. It helps us quickly spot if we need to clean before plotting or calculating. Our comment means we are searching for missing entries. ISNL finds missing data and sum adds up how many in each column. Running the cell now. Look for any number bigger than 0. That tells us if cleanup is needed. Just to be safe, we fill missing numbers with their columns mean. For text columns, we use missing. This prevents errors in plots and calculations. This comment notes our fix for missing values. Here, any missing numbers get replaced by the column average. We overwrite our original df with this clean version. We spot check for nulls again, just to be certain. Running the cell now. Try plotting again if you found missing data before. It should work better now. Compare distributions, multiple groups. We can see differences in data by splitting into groups. Let us look at how tips differ by gender using histograms and boxplots. Running the cell now. Let us compare how different genders tip by plotting two histograms together. Colors help us spot who tends to give which kind of tips. This comment describes our grouped histogram goal. Figure size again fits both histograms. We add a hue for gender so you see both groups, and adjust transparency so overlap shows. A title tells us what is compared. X-axis is still tip sizes. Y-axis counts up bills. Show the side-by-side graph. Running the cell now. Can you think of other ways to split groups? Try a smoker draws time. Let us look at Boxplot split by whether the person is a smoker or not. This can reveal if there is a tipping difference between smokers and non-smokers. We note now that the comparison is between smoking groups. The plot size is set to be more compact. Boxplots are grouped by smoker status. A new informative chart title. X label is either smoker or not. Y label is for tip values. The chart is displayed. Running the cell now. Do you notice differences between the groups in median or spread? Customizing plots, style and context. You can easily change the look of plots with Seaborn's built-in themes. Let us see how a simple setting can make charts look different. Running the cell now. Let us update our chart style to a dark grid. This makes plots easier to read, especially for presentations. Now we will quickly remake one plot so you see the effect. In this comment, we tell Python to change the overall look. Seaborn's A Dark Grid theme adds background grid lines. Figure size is set to fit the content. We redraw our tips histogram with the new style and a fresh color. A new title matches our change. This shows the style chart. Running the cell now. Try different styles, white grid, dark, ticks, or white. Which one do you like most? Challenge, your turn. Try creating a scatterplot or boxplot using two different columns or groups. Can you find an interesting pattern? Try customizing the color or style as you wish. Running the cell now. Let us do a fast mini project. We will loop through all the main number columns and draw their histograms. It is a handy way to scan a whole dataset for patterns and odd values. In this section, we make a for loop to cover 3 columns at once. Each chart uses the same size for fair comparison. For every column, we build a histogram as before. We pick blue so all 3 charts share the same look. The plot title uses the name of our column. The X label shows the column name, nicely formatted. The Y label always counts up bars. We show each chart after it is made. Running the cell now. Quick recap, you now know how to do histograms, boxplots, and scatterplots for deeper data discovery. Please like and subscribe if you enjoyed exploring data this way. Recap, what did we learn? You learned how to draw histograms for distributions, boxplots for summaries, and scatterplots to see relationships. You saw how grouping and style help bring your findings to life. Now you have the power to dig into any dataset visually. Running the cell now. Next steps and call to action. Try using these plots on your own data or another Seaborn example. Tell us in the YouTube comments what you would like to visualize next. Like, subscribe, and share if you found this lesson helpful. Running the cell now.